Bio-cybernetics, written by me, narrated by me. Special edition, part 1. The illusion of simple action. It seems at first glance that human action begins with intention, that we decide and then we act. But this assumption dissolves the moment we examine even the simplest movement in detail. Take, for instance, the act of picking up a pen. What appears to be a singular, unified decision is, in reality, the endpoint of an extraordinarily complex cascade of processes that unfold beneath conscious awareness, involving perception, prediction, coordination, correction, execution, all occurring within fractions of a second. The organism does not wait for conscious instruction. It operates through pre established patterns that have been shaped by repetition, adaptation, and biological design. As Maxwell Mode suggests, the human being functions as a goal seeking system, not one that consciously calculates every step, but one that is already organized around achieving outcomes through automatic regulation. You do not consciously contract each muscle fiber in your hand. You do not compute the necessary grip strength or trajectory or every micro decision. And yet, the action is executed with remarkable precision. This reveals a critical inversion. What we experience as control is often merely awareness of a process already in motion. This perspective becomes even more compelling when we consider the observations of Dr. John Hucklings Jackson, who emphasized that no movement can be reduced to a single anatomical function. Picking up a needle, for example, is not only a hand action, it is a total organism response. Vision first must identify the object and its spatial location. Depth perception must calculate distance. The motor cortex must generate coordinated signals. The cerebellum, the small brain, must fine tune the movement. Sensory feedback must continuously adjust errors in real time, and all of this must occur seamlessly without fragmentation. If any component fails, the entire act collapses. What appears simple is in fact an emergent property of integrated systems operating in synchrony. The implication is profound. There is no isolated action, only systemic coordination. Dr. Weiner, as referenced by Mautz, pushes this idea further by highlighting the impossibility of conscious micromanagement. If a person were required to consciously direct each muscular contraction involved in picking up a pencil, the task would become not only difficult but impossible. The delay introduced by conscious processing would disrupt timing, coordination, and fluidity. Instead, the nervous system relies on what we might call stored solutions, patterns of action that have been refined through experience and encoded into our nervous system. These patterns allow for immediate execution without deliberation. In modern neuroscience, this aligns with the concept of procedural memory, a form of memory that governs skills and actions without requiring conscious recall. Walking, writing, driving, all are examples of complex behaviors that become automatic through repetition. Once internalized, they operate independently of conscious control. This raises an uncomfortable question: how much of what we do is truly chosen and how much is simply executed? The story of the centipede, with its 100 legs, illustrates this paradox with striking clarity. A creature with dozens of legs moves effortlessly until it begins to think about how it moves. The moment attention is directed toward the mechanics of each step and leg, coordination breaks down. The system that once functioned fluidly becomes rigid and inefficient. This phenomenon is not limited to insects only. It appears in humans under pressure, when an athlete chokes, when a speaker forgets a well rehearsed line, when a skilled performer suddenly becomes self conscious, and so on. Psychologists refer to this as analysis paralysis. Conscious attention, when misapplied, interferes with automatic processes that are better left undisturbed. In other words, there exists an optimal division of labor within the mind. Some processes must remain unconscious in order to function properly, effectively. Attempting to bring them into conscious control does not enhance performance, it degrades it. This leads us to the fundamental limitations of consciousness itself. Conscious thought is sequential. It can process only a limited amount of information at any given moment. It operates in a narrow bandwidth, focusing on one element at a time, positive or negative. In contrast, the subconscious, or more accurately, the non conscious processes of the brain, operate in parallel. They integrate sensory input, regulate internal states, anticipate outcomes, and coordinate actions simultaneously. Estimates vary, but it is widely accepted that unconscious processing is vastly faster and more efficient than conscious deliberation. While consciousness might process dozens of bits of information per second, the broader nervous system handles millions. This disparity suggests that consciousness is not the primary driver of behavior, but rather a late stage interpreter, a system that constructs a narrative around actions that have already been initiated. If this is true, then the role of consciousness must be reconsidered. It is not the commander, but the commentator. It does not initiate most processes, but it observes and explains them. This aligns with findings from neuroscience experiments, such as those conducted by Benjamin Libet, where a brain activity associated with decision making was detected before participants reported conscious awareness of having made a decision. While these findings remain debated, they point toward a consistent theme. The sense of volition might emerge after the fact as part of the brain's effort to maintain a coherent sense of self. And here the illusion becomes complete. We believe we act because we choose, but in many cases we choose because we have already begun to act. Part 2: Conditioning, Habit, and the Programmed Human. If the first illusion is that action is simple, the second illusion is that behavior is free. At the surface level, human beings appear to choose, to decide, to act, to change direction, to set goals, and so on. But when we begin to examine behavior across time, across repetition, and across environments, a different picture begins to emerge. Behavior is not random, nor is it entirely self generated. It is shaped, reinforced, suppressed, and patterned through interaction with consequences. What we call choice is often the visible endpoint of an invisible history. This becomes evident in the work of Ivan Pavlov, whose experiments with dogs reveal that organisms do not merely react to stimuli, they learn to anticipate them. By repeatedly pairing a neutral stimulus, a bell, with a biological significant one, food, Pavlov demonstrated that the organism begins to respond to the signal itself, not because of its intrinsic value, but because of its predictive association. The dog salivates not to the bell, but to what the bell means. This is a critical shift. The nervous system is not reacting to reality as it is, but to patterns it has learned to interpret. The bell becomes a trigger, a symbol, a shortcut, a compressed representation of unexpected outcome. But Pavlov's findings are only the beginning. Edward Thorndike extends this logic through his puzzle box experiments with cats, where behavior is not passively conditioned but actively shaped through trial and error. Initially, the animal behaves chaotically, chaotically, scratching, biting, pushing randomly, but over time, specific actions that lead to escape are reinforced, while ineffective ones are discarded. From this emerges the law of effect. Responses followed by satisfying consequences become more likely, while those followed by discomfort become less likely. What is crucial here is not intelligence in the abstract, but selection through consequence. Behavior is sculpted not by insight alone, but by feedback loops. To complete the picture of conditioning and extend it beyond simple stimulus response chains and associations, we must add the crucial work of Wolfgang Kohler, whose experiments with chimpanzees on the island of Tenerife introduced something that at first glance appears to break the mechanical model of behavior: insight learning. Unlike the gradual trial and error learning described by Edward Thorndike, Kohler observed that chimpanzees, when faced with a problem, such as reaching bananas placed out of reach, would not always engage in a random activity, but instead pause, seemingly reorganize the situation, and then suddenly perform a correct consequence, stacking boxes one over the other, joining sticks. What he describes as a restructuring of the perceptual field, or what he called Einsicht, German for insight, Einsicht, suggesting that behavior can emerge not only from a reinforcement but from a reconfiguration of how the situation is perceived. And yet, even this insight is not outside the system but dependent on prior experience and the organism's capacity to reorganize known elements, so that what appears as intelligence is still bounded by structure, which brings us closer to human cognition, where problem solving often feels like a sudden revelation, but is in fact the recombination of previously encoded patterns. At the same time, if you move from organized behavior to its biological limits, we encounter phenomena that seem almost paradoxical, such as the fact that a chicken can continue to run and behave for several seconds after decapitation, a striking demonstration that coordinating movements does not necessarily require the full presence of what we call consciousness or the self, but can be sustained by spinal and peripheral neural circuits, revealing that the organism is distributed rather than centralized. This observation finds an even more systematic exploration in the experimental work of William James, who studied reflexes and autonomic behaviors, including those in decapitated frogs, showing that even in the absence of the brain, the frog can perform complex actions, whipping away irritants, adjusting posture, suggesting that what we call purposeful behavior may, at least in part, be embedded in the lower neural structures, so that intention is not always required for organized action, which in turn challenges the assumption that consciousness is the origin of behavior. In another experimental settings, the scientists experimented upon a cut off head of a dog, completely separated from its body. Then they stimulated this head with lemon juice or whatever, and the dog, even without body, tried to bark and to lick its mouth to remove the juice. One of James' most provocative formulations, often referred to as the James Lang theory of emotion, where he reverses the common intuition by proposing that we do not run because we are afraid, but rather we feel fear because we run, meaning that the bodily response precedes and generates the emotional experience, so that emotion is not the cause of action but its interpretation, and this inversion has profound implications. It suggests that what we experience as inner states might be constructed from externalized behavior and physiological change, reinforcing the idea that the self is interpretive rather than initiatory. And yet, when we attempt to locate a final ground for this interpretive system, we encounter conceptual paradoxes, such as the anecdote often attributed to philosophical discussions in James' time, where a person claimed that the world rests on the back of a turtle, and when asked what the turtle rests upon, then the answer becomes an infinite regress, another turtle, and so on, illustrating the difficulty of finding an ultimate foundation, much like the earlier homunculus problem. Homunculus, from Latin meaning small or little human, where every attempt to explain the system by inserting another controlling entity only postpones the question rather than resolving it. From here, the analysis returns to the organism itself, particularly to the relationship between pleasure, reproduction, and meaning, because from a biological standpoint, behaviors such as sexuality are oriented toward the transmission of genes, yet subjectively experienced as pleasure, creating a functional bridge between survival and experience, so that the organism is motivated to reproduce not by abstract goal, but by immediate reward. And this becomes almost absurdly clear in the hypothetical story of Martians observing human behavior, where upon being told that humans engage in sexual activity to propagate their genes, they might ask, if that is the goal, why such urgency? Why such repetition? Why such intensity? A question that exposes the gap between biological function and subjective experience, revealing that the organism does not act based on ultimate purposes but on proximal incentives. so that what we call meaning, intention, or desire might in fact be layered interpretations of deeper processes that operate without reference to or conscious understanding. Thus, from Kochler's chimpanzees to decapitated chickens and frogs and dogs, from James' theory of emotion to the paradox of the turtles and the Martian question about human desire, a consistent pattern emerges. Behavior, perception, and experience are not anchored in a single central agent, but distributed across systems, shaped by structure and interpreted after the fact, leaving us once again with the central tension between the appearance of control and the underlying mechanisms that make that appearance possible. The principles of learning and conditioning reaches its most systematic form in the work of B.F. Skinner, who eliminates ambiguity and constructs environments where behavior can be observed, measured, and controlled with precision. In the so-called Skinner box, animals are placed in controlled condition where specific behaviors, pressing a lever, picking a key, produce specific outcomes: food, avoidance of shock. What Skinner demonstrates is not merely that behavior can be reinforced, but that the schedule of reinforcement profoundly alters its persistence. When rewards are delivered consistently, behavior stabilizes. Dogs systematically rewarded for their performance, for their successes, while doing tricks. Dogs rewarded for their tricks performed better than those whom were punished for their mistakes. The same logic is applied to humans. What Skinner demonstrates is not merely that behavior can be reinforced, but that the schedule of reinforcement profoundly alters its persistence. When rewards are delivered consistently, behavior stabilizes, but when rewards are delivered unpredictably, intermittently, behavior becomes more resistant to extinction. This is not a trivial observation. It is the mechanism underlying gambling addiction, social media engagement, pornography, and compulsive checking behaviors. The organism continues to act not because it is consistently rewarded, but because it might be. And here we encounter a deeper layer: the distinction between habit and dependency. A habit A habit is a learned pattern, a behavior repeated under similar conditions until it becomes automatic. A dependency, however, involves a psychological and physiological need, a state in which the absence of a stimulus produces discomfort or distress. Humans tend to confuse the two because both involve repetition, but their underlying dynamics differ. A habit can exist without craving, a dependency cannot. Yet both are built upon the same foundation: repeated associations between action and outcome. The concepts of Sigmund Freud and his theory of his conception about the principle of the pleasure and displeasure, and the three aspects of the psyche: the superego, the ego, and the id, the instinctual drives. When someone is, so to say, addicted, his ego is mostly overwhelmed by his ID, instinctual drives, and he mostly is applying the principle of pleasure and displeasure. He is seeking pleasure and trying to reduce displeasure. Carl Jung noted four basic functions of the psyche: thinking, feeling, sensing, and intuition. And they those four functions are affected by by the it, by the ego, and by the superego. And when someone is most of the time preoccupied with his lower needs, we say he is less conscious or unconscious. Behavior is not simply what we do, it is what has been encoded through experience. Every action, from the simplest to the most complex, involves both sensory input and motor output. The organism continuously maps perception to response, building internal models of if this then that. Over time, these mappings become increasingly efficient, requiring less conscious intervention. What begins as effort becomes ease. What begins as choice becomes routine. And yet, this efficiency comes at a cost. Because once a behavior is encoded, it does not require justification, it simply executes. This is why individuals often find themselves repeating patterns they consciously reject. A person might decide to change, to act differently, to break a cycle, and yet, under pressure, revert to familiar responses. This is not a failure of willpower, it is the activation of a deeper program. The system defaults to what it knows, not what it prefers. To understand this, we must consider the role of emotional reinforcement. Not all rewards are external. Some are internal: relief from anxiety, reduction of tension, avoidance of discomfort. A behavior that reduces internal distress, even temporarily, becomes reinforced. This is the basis of many maladaptive patterns: avoidance, procrastination, self sabotage. The immediate, the immediate relief acts as a reward, even if the long if the long-term consequence is negative. The organism prioritizes short-term regulation over long-term optimization. In this sense, behavior is not irrational, it is locally adaptive. But locally adaptive does not mean globally beneficial. This distinction becomes critical when we examine human motivation. Broadly speaking, there are two primary forms: negative motivation, driven by the desire to avoid pain or aversive conditions, and positive motivation, driven by the anticipation of reward or pleasure. Both are effective, but they produce different patterns of behavior. Negative motivation often leads to urgency, anxiety, and short term action. Positive motivation fosters exploration, persistence, and long term engagement. However, both operate within the same framework. Behavior is guided by expected outcomes. And here lies the final insight of this section. We do not act based on what is, we act based on what we expect. Expectation, in turn, is shaped by our past experience, which means the past is not behind us, it is embedded within us, guiding every movement. Part 3: Perception, Reality, and the Fragile Construction of Experience Extended. If behavior is shaped, then perception is filtered, and perhaps even more radically constructed. The common assumption is that we see the world as it is, that perception is a direct window into reality, but this assumption does not survive scrutiny. What we call seeing, hearing, or feeling is not the passive reception of external truth, but the active organization of sensory input into meaningful patterns. The brain does not record reality, it interprets signals. If behavior is shaped, then perception is filtered and perhaps even more radically constructed. And the deeper we go into this idea, the more it dissolves the naive assumption that we see the world as it is, because what we call seeing, hearing, or feeling is not a passive reception of reality but an active organization of sensory input into patterns that are already influenced by prior experience, expectation, and internal structure. At the most basic biological level, this process begins with the dendrites, axons, and synapses, receptive, receptive transmitting and connecting elements of the nervous system, where no meaning exists in itself, only electrochemical activity, gradients, and impulses, and yet through repetition, correlation, and reinforcement, these signals organize into networks that function as models of the world, so that the brain does not store reality but approximations of it, compressed and optimized for survival rather than accuracy, which immediately implies that what we perceive is always a reconstruction rather than a direct encounter. The constructive nature of perception becomes even clearer when we integrate the work of George Kelly, who proposed that human beings function as personal scientists, constantly forming and testing what he called personal constructs, bipolar dimensions such as safe, dangerous, good, bad, success, failure, through which we interpret experience. These constructs are not fixed truths but flexible hypotheses, yet, once stabilized, they act as filters that determine what is noticed, how it is interpreted, and what is ignored, so that two individuals might inhabit the same physical environment but effectively live in different psychological realities, each structured by their own system of constructs. And when incoming experience does not fit these constructs, the system either adapts or distorts the perception to maintain coherence, revealing that perception is not only selective but self protective. At the same time, these constructs do not arise in isolation but develop through stages, as described by Erik Erikson, whose psychosocial model shows how early experiences of trust, autonomy, initiation, and identity shape the fundamental expectations through which perception operates, so that a child who develops trust perceives the world as fundamentally reliable, while one who develops mistrust perceives threat even in neutral situations, meaning that perception is developmentally conditioned, layered over time, and anchored in emotional experience which persists in adulthood as a background structure guiding interpretation without requiring conscious awareness. This developmental layering connects directly to the distinction made by Eric Fromm between the modes of having and being, where perception itself can be oriented either toward possession and control or toward experience and participation. In the having mode, the individual perceives the world in terms of ownership, accumulation, and utility. Objects, people, even ideas become things to acquire, while in the being mode, perception becomes more immediate, process oriented, and less distorted by the need to control, allowing for more direct engagement with reality, though never entirely free from interpretation, so that even the structure of perception reflects deeper existential attitudes. Further reaching this framework is the distinction introduced by Abraham Maslow between D cognition, deficiency cognition, and B cognition, being cognition, where D cognition is driven by lack, need, and survival, leading to perception that is selective, biased, and oriented toward filling deficits, while B-cognition emerges in states of relative fulfillment, allowing perception to become more holistic, less defensive, and more receptive to complexity. What Maslow described in his studies of self actualizing individuals as moments of peak experience, where reality is perceived with greater clarity, unity, and richness. Historically, Maslow's work emerged as a response to both behaviorism and psychoanalysis, attempting to reintroduce the study of healthy functioning, and in this sense, his distinction reveals that perception itself can evolve, shifting from a narrow, survival driven filter to a broader, more integrative awareness. However, in its most refined form, perception remains vulnerable to distortion, as seen in phenomena such as depersonalization and derealization, where the integration between sensory input and meaning breaks down, producing a sense of detachment from self or environment, demonstrating that the feeling of reality is not inherent but constructed through alignment between perception, memory, and emotion. Similarly, déjà vu and jamais vu illustrate how slight disruptions in neural timing or pattern recognition can create false familiarity or unfamiliarity, suggesting that perception and memory are not separate systems, but overlapping processes that continuously interact, sometimes reinforcing, sometimes conflicting, leading to experiences that challenge the stability of reality itself. This interplay becomes even more significant when we consider that perception is intertwined with thought, forming a feedback loop in which thoughts arise from perception and simultaneously shape it, so that what we think influences what we see, and what we see reinforces what we think, creating self sustaining cycles that can stabilize belief systems or trap the individual within rigid interpretations. A negative expectation generates selective attention towards confirming evidence, which reinforces the expectation, while alternative interpretations are filtered out, illustrating that perception is not neutral but guided by prior structure. From a biological standpoint, this loop is supported by neural plasticity, the strengthening of synaptic connections through repeated activation, so that patterns of perception and interpretation become increasingly automatic over time, requiring less conscious effort and becoming more resistant to change. Which explains why deeply ingrained beliefs persist even in the face of contradictory evidence. Psychoanalytically, this aligns with the idea that unconscious processes shape conscious experience, whilst psychologically it reflects the tendency toward cognitive consistency and coherence. Thus, when we speak of perception, we are not referring to a simple sensory process, but to a multi layered system involving biological mechanisms, developmental history, cognitive constructs, emotional states, and existential orientation, all interacting to produce what you experience as reality. And the implication is profound. Reality as we know it is not simply out there, but co-created by the organism, filtered through structures that both enable and limit understanding, so that to change perception is not merely to see differently, but to reorganize the entire system through which seeing occurs. All this brings us to a deeper philosophical distinction, the difference between form, content, and meaning. Form refers to the structure, the arrangement of elements, the pattern through which information is presented. Content, however, refers to the raw material, the signals, images, words, or sensations themselves. Meaning is not contained in either form or content. It is generated by the observer, by the system interpreting the input. The same content presented in a different form can produce a different meaning. The same form, filled with different content, can evoke entirely different responses. Meaning is not inherent, it is assigned. This has profound implications for human experience. It means that our emotional reactions are not determined solely by events, but by the meanings we attach to them. Two individuals can encounter the same situation and respond in radically different ways, not because the situation differs, but because their internal models do. One perceives threat, another opportunity, one experiences loss, another transformation. In this sense, perception is not just a sensory process, it is a psychological act, and it is deeply intertwined with thought. A thought can arise as a reaction to a sensation, a feeling of discomfort, a visual cue, a memory, but it can also act as a cause, generating new sensations and emotions. This bidirectional relationship creates a feedback loop. Through influence feelings and feelings influence thoughts influence feelings and feelings influence thoughts. A negative thought will produce a negative emotional state, which in turn reinforces the original thought, creating a self sustaining cycle. Conversely, a shift in interpretation can alter the emotional response, even if the external conditions remain unchanged. This is why the correlation between thought and reaction is so central. It is not merely that we think and then feel, it is that each reinforces the other in a continuous loop. Even simple reflexes illustrate this principle. When you tap someone unexpectedly, they turn, a physical response to a stimulus. But in more complex scenarios, the stimulus is not physical but symbolic, psychical, a word, a memory, or expectation, a dream. The reaction, however, can be just as real: increased heart rate, tension, avoidance behavior, and so on. The body responds not only to what is, but to what is perceived to be, and perception, as we have seen, is constructed. It is as if, after observing how behavior can be directed, synchronized, and even hijacked from the outside, the next logical step is to understand how the organism orients itself in the world at all, because before there is action, there is perception. And before there is a choice, there is interpretation, so that the real question is no longer how do we act, but rather how do we understand where we are. In insects, for example, this orientation often depends on structures that appear insignificant at first glance, but in fact play a fundamental role, such as the antennae of ants from the family Formicidae, which function as highly specialized sensory organs capable of detecting chemical signals, pheromones, that encode information about pets, danger, food sources, and social hierarchy, so that for the ant, space is not primarily visual but chemical. In other words, it sees through smell. And when these antennae are damaged or removed, the ant loses its ability to orient, begins to move chaotically, fails to distinguish between colony members and outsiders, as if reality itself disintegrates because the coordinate system through which it interprets the world has collapsed. In other words, orientation is not an external given but an internal construction. And this principle extends to a higher organism as well, where, for instance, in dogs, olfaction plays such a dominant role that disruption of olfactory pathways leads to drastic behavioral change. The animal loses the ability to distinguish between male and female, and even motivation becomes weakened so that decisions do not disappear but lose their foundation. It is as if this leads us toward a deeper realization. Perception is not a passive reflection of the world, but an active filtering process. a selection of what is meaningful. And here the analogy with humans becomes clear. Just as a chef refines taste through subtle discrimination of aromas, so every human being makes decisions based on signals that often remain outside conscious awareness, so that what we call intuition might be understood as unconscious processing of sensory data. However, when we return to biology, we encounter even more radical forms of internal regulation, such as in the glass frog, which can redistribute its blood and concentrate all its red blood cells in the liver, rendering its body nearly transparent. In other words, it disappears not through external camouflage but through internal transformation, demonstrating that the organism can manipulate itself in ways that seem almost impossible. And here the analogy to humans becomes unavoidable. We too constantly alter our internal states, heart rate, hormonal balance, muscular tension, in response to thoughts, emotions, and interpretations, often without awareness of the underlying mechanism, so that the internal environment is not stable but dynamic. As if the same principle manifests in the chameleon, whose color changes are not merely camouflage but the result of complex neural and cellular processes, where nanostructures within the skin reorganize light reflection, meaning that color expresses not only the external environment but also internal states, such as stress, temperature, social interaction, and so on. In other words, adaptation is not simply a reaction to the world, but an interaction between inner and outer processes, so that the organism does not merely adjust to reality, but actively participates in constructing the reality it experiences. However, here emerges a subtle but decisive boundary between what we might call persona, from the Latin mask, and what we call personality, because if the organism reacts automatically while consciousness interprets these reactions, then the self, the true self, might not be a central controller, but rather an interface, a point of intersection between biology and meaning. In other words, the boundary between organism and personality is not fixed but fluid, almost transparent, thin as cigarette paper. And within this thinness lies the potential for confusion, because one might mistake automatic reactions for conscious decisions, or conversely, fail to recognize genuine agency. It is as if, at this point, we transition toward a deeper understanding of the human being, because if perception can be distorted, if orientation can be lost, if internal states can shift without conscious control, then the question of who acts becomes increasingly complex, leading inevitably to different models of the human, not merely as biological organisms, biological organism, but as psychological and philosophical construct. Thus, after tracing how the organism perceives, orients, and is influenced by both internal and external forces, we arrive at the question of the human being, not as a body, but as an idea, a model, an interpretation of itself. Because if everything so far suggests that behavior can be programmed, synchronized, and even hacked, then who is it that says I? At this point, various images of the human emerge, each attempting to capture its essence, and Viktor Frankl proposes a triad that restores a certain dignity to human existence, the so called Homo patiens, from patior, to suffer, the human as a being capable of enduring suffering and assigning meaning to it. Homo amans, from amo, to love. The human as a being that transcends itself through love. And Homo faber, from faber, maker or craftsman. The human as a creator who transforms the world through action. So that in this framework, the human is not merely a biological organism, but a being capable of choosing its attitude towards circumstances, preserving an inner freedom even under extreme constraint. However, this elevated model stands in tension with more deterministic views, such as that of Cesare Lombroso, who introduces the concept of homo delinquens, from Latin delinquere, to deviate or transgress, suggesting that criminal behavior is rooted in biological predispositions, so that the individual does not fully choose but is structured towards certain outcomes, and here freedom appears limited by form. To this we may add the model of the so-called Homo economicus associated with Adam Smith and later economic theory, where the human is reduced to a rational calculator, maximizing utility so that behavior becomes optimization rather than meaning or morality, as if these models define three dimensions: the human as meaning seeking, as biologically determined, and as rationally calculating. Yet, none fully answers the question who acts, because each presupposes a central agent. And it is precisely here that one of the most intriguing and troubling concepts appear: the homunculus, from Latin for a little man, an idea with roots in alchemy, alchemy, where it was believed that a miniature human could contain the full essence of a person. But in modern science, this becomes a problem rather than a solution, because if we assume there is a little observer inside the brain controlling everything, we immediately face an infinite regress. Who controls the controller? And thus the so-called homunculus problem reveals that consciousness cannot be explained by inserting another consciousness within it. And yet, in neuroscience, the sensory motor homunculus, the cortical maps of the body, show something equally revealing. Certain body parts, such as the hands and lips, occupy disproportionately large areas of the brain, meaning that the body, as represented in the brain, is not realistic but functionally distorted, so that even our most immediate experience of embodiment is already a constructed map rather than direct reality. As if this returns us to the central question: if there is no central self, if perception is constructed, if behavior emerges from processes outside awareness, then what remains? The answer is not simple, but it may be stated as follows: the human being is neither fully free nor fully determined, but a system operating within constraints, while retaining the capacity to become aware of those constraints. So that freedom is not the absence of programming, but the ability to recognize it. It is as if within this framework emerges the image of the future human, sometimes referred to as Homo sapientissimus, depicted as a being with an enlarged skull and brain, reduced physical structure, and minimal bodily function, only three fingers, almost pure intellect. Yet this extreme vision reveals a danger: the separation of mind from organism, because cognition cannot exist independently of the biological system that sustains it, and thus the question remains open, not how to escape the system, but how to live within it without being entirely consumed by it. And let's go one layer deeper, because once we have established that perception is constructed and the self is modeled, we must now distinguish between what is perceived and what is remembered, since the confusion between these two gives rise to some of the most fundamental errors in human judgment. A perception is not a passive recording but an active, time bound organization of sensory input, an immediate synthesis of signals into a coherent experience, while memory is not an exact reproduction of that experience but a reconstruction, a partial and often distorted reactivation of previously encoded patterns, so that what we call remembering is less like replaying a recording and more like rebuilding a skein from fragments, influenced by current emotional state, expectation, and context. And this is why memory is inherently selective, blurred, and incomplete, despite the intuitive belief that it is precise, which leads to a paradox. We often trust memory more than perception, even if perception itself is already filtered. In other words, we do not experience reality directly, and we do not even remember our filtered experience accurately, which means that both our present and our past are constructions, layers upon constructions. At the same time, it is striking that we are far more aware of our external environment than of our internal processes, as if consciousness is oriented outward by design, prioritizing survival relevant stimuli over introspective accuracy so that we can describe in detail what is happening around us, yet remain largely ignorant of the mechanisms generating our own thoughts, emotions, and decisions. This asymmetry suggests a functional hierarchy, what we might call, in biological terms, an economy of attention, where the organism allocates resources toward what is immediately actionable, leaving internal processes to operate automatically. And here we encounter what could be described as a principle of minimization of harm and maximization of gain, embedded deeply within the structure of the nervous system. If presented with two punishments, a prick with a needle or a stab with a knife, the organism will prefer the lesser pain. And similarly, when presented with two rewards, it will gravitate toward the greater benefit, illustrating a fundamental gradient based orientation, where behavior is guided not by absolute values but by relative differences, a principle that operates beneath conscious reasoning and shapes decision making at every level. Within this framework, the distinction between persona, self, organism, and identity becomes crucial. Because these terms are often used interchangeably yet refer to different layers of the same system. Persona, again from Latin persona, meaning mask, originally referring to the theatrical mask through which sound, personare, to sound through, was projected, represents the social interface, the role oriented aspect of the individual, shaped by expectations and context. The version of oneself presented to others, the organism, by contrast, is the biological substrate and base, the totality of physiological processes, neural activity, blood, hormonal regulation, reflexes, and inherent structures that operate largely outside awareness, what we might call the machinery of existence. The self then emerges as an experiential construct, a point of reference generated by the integration of perception, memory, and ongoing activity, subjective center, not a fixed entity but a continuously updated model, An identity from the Latin identitas, meaning sameness or continuity, represents the narrative layer, the story the system tells about itself in order to maintain coherence across time, linking past, present, and anticipated future into a unified sense of who I am. These layers do not operate independently but interact continuously, often producing tension and contradiction. The persona might demand conformity, the organism might generate impulses, the self might attempt to interpret them, and identity might attempt to stabilize them into a consistent narrative, so that what we experience as a unified I is in fact a dynamic equilibrium between competing processes. This becomes particularly evident when we examine biological examples that reveal how behavior can be structured with minimal or even absent conscious mediation, such as in the key case of bees, Apis mellifera, where the differentiation between worker and queen is not a matter of genetic destiny alone, but of nutrition, specifically the administration of royal jelly, a secretion that alters developmental pathways so profoundly that a genetically identical larva becomes a queen, illustrating that identity, even at a biological level, is not fixed but modifiable through environmental input, and that what appears as hierarchy or destiny might in fact be the result of selective conditioning. An even more striking example is found in the behavior of the Sphex wasp, whose highly stereotyped actions, paralyzing prey with precise injections of venom, placing it at the burrow entrance, entering to ins- inspect, and only then dragging the prey inside, can be disrupted by the smallest interference, such as moving the prey a few centimeters away, causing the wasp to repeat the entire routine again and again, as if caught in a loop, revealing a form of rigid programming that operates with astonishing precision yet minimal flexibility. And it is precisely this kind of patterned automatic behavior that invites comparison with the work of Wilder Penfield, who, through direct electrical stimulation of the cerebral cortex with a needle, for example, during neurosurgical procedures, demonstrated that complex actions, sensations, and even vivid experiential fragments could be elicited without the patient's conscious intention, leading him to speak of what he called the record of experience embedded in the brain, and to distinguish between the executive self, the observing, interpreting function, and the activated neural circuits that produce movement or memory. So that when a patient's arm was raised by stimulation, the patient might insist, "I didn't do that, you did it," revealing a dissociation between action and agency. Revealing a dissociation between action and agency, between movement and authorship, suggesting that voluntary action might in part be the triggering of pre existing neural programs rather than the spontaneous creation of behavior. Penfield also makes a difference between psychic and psychical. Yet, if we descend even deeper into biological mechanisms, we find that such precision without central awareness is not exceptional but ubiquitous, as illustrated by the mosquito, whose feeding apparatus is not a simple needle, but a highly specialized composite structure composed of multiple microelements. The labium acting as a sheet, bending away as the proboscis penetrates the skin, while inside six needle-like stylets perform distinct functions. The mandibles and the maxillae saw through the skin. The hypopharynx injects saliva containing anticoagulants and anesthetic compounds that prevent clotting and reduce detection. And the labrum acts as a channel through which blood is drawn, guided by chemical receptors that detect capillary flow, so that what appears to us as a single act is in fact a coordinated sequence of micro actions, each executed without deliberation, each guided by evolutionary programming rather than conscious choice. Similarly, the sting of the honeybee represents an intricate mechanism where the barbed stinger, connected to a venom sac and muscular apparatus, continues to pump venom even after detachment, independent from the body of the bee, driven by autonomous muscular contractions, effectively making the act of stinging a self propagating process, independent of the organism's continued control, illustrating once again that action can persist beyond the agent, that behavior can outlive intention. When these biological examples are placed alongside Penfield's findings, the knowledge deepens. Just as the Sphex wasp repeats its sequence, the mosquito executes its feeding protocol, and the bee stinger continues its function autonomously, so too the human nervous system contains layered circuits capable of initiating and sustaining behavior without conscious authorship, leading Penfield to question the nature of the self and to propose that what he called the mind might not be reducible to the brain's mechanical operations alone. Yet at the same time, his experiments revealed that the contents of consciousness, sensations, memories, movements, could be artificially evoked, suggesting that the boundary between voluntary and involuntary is far more permeable than commonly assumed. In this light, the distinction between perception and memory, between persona and organism, between identity and self, converges towards a single, unsettling insight that the human being is not a simple unified agent, but a multi layered system in which biological mechanisms, conditioned patterns, and interpretive structures interact continuously, sometimes aligning, sometimes conflicting, and that what we call consciousness might not be the originator of action but its interpreter, observer, what could be described as a narrative function, organizing events into a coherent story after they have already begun to unfold, so that the question who acts dissolves into a more complex inquiry, not the search for a central controller, but the examination of how distributed processes coordinate, overlap, and occasionally misalign, leaving us in a position where we are neither fully determined nor fully free, but situated within a system that allows awareness itself to become the narrow, fragile space in which reflection and perhaps transformation can occur. Thank you for going this far. If you want to support me, you can hit subscribe. You can like my page in Facebook. And if you're interested in my services and my products and my business, you can write to me through Facebook. I wish that you can understand me. And I hope this information I gave to you will help you realize some things and will make you successful, at least in the long term. If you have difficulties understanding my course of bio-cybernetics, you can listen to this couple of times. Actually, you can make it a second nature to you. I wish you luck, success, And let me tell you that more free content is coming. If you enjoyed this, please subscribe and like my Facebook page. Thank you.